A lot of the functionality of QGIS comes from plugins. Those are independent tools that somebody has written to work with QGIS. We're going to use one that creates a terrain profile, or allows you to create a line and then shows the change in elevation along that line. So we go under Plugins, Manage and Install Plugins, and then when that loads up, we're going to go to All here and search for Profile Tool. This top one here, go ahead and install plugin. It'll find the data, bring it in, and then you'll have that tool, which will pop up here. 3, 2, 1, there it is. Go ahead and close there. Let's say that you want to park at this corner and go to the top of this hill. Use the Terrain Profile tool. That will load this in. You need to click on your elevation model in the Layers tab, and then tell it to Add Layer. Then, 1 click at your start point, 2 clicks at your end point, and that shows you the change in elevation along that line. You can also do 1 click to start, 1 click to add a vertex, and go every which way, however you want to go, until you end your line there. And then you're going along there, back and forth, and back and forth, and back and forth. Another common use of this tool is to evaluate stream crossings for roads. So let's pretend this road wasn't here, and we want to build a road where it happens to be. So we'll click here, double click on the other side of it, and we can see where the low point is, and right there, that's where the stream crossing is. Here's a trickier case. So you see all this sort of washed out area. This, if you look at the Google satellite, that bridge is washed out, this is no longer in use. And that's where the stream is now, but you can see it's wandered its way all throughout that floodplain there. So let's uncheck that and that. And it looks like we have old channels all throughout. So let's go ahead and use the Profile tool and go from one bank to the other. So right here at our lowest point, it looks like that is our current stream bed, and we can actually check on our Google satellite and confirm that. So we can see we're going down that embankment there. Flat ground all throughout there. There's our lowest point. And then as we go up here, we'll cross a bunch of old channels, and all of those, if this for whatever reason got plugged up or blocked by a fallen tree or something, one of those could again carry water and get carved out. And in this case, our units on the y-axis are feet. So we go from about 830 feet to 824 feet there. You see just to the left of my mouse, that's where the reading is on the y-axis, it's telling you. And you quickly drop down to about 800 feet, so you lose 25 feet there. Then you're going from this bench here, about 800 feet, down to 796. So a difference of 4 feet, and that's pretty easy to fill up with sediment in one spring freshet. And looking at this, you can see how much this sediment has moved around. And see, we're still pointing this tool at that elevation model, but we can use the air photo as a bit of guidance. So you can see that goes down over our bench from about 830 down to 805, so a 25-foot drop there. And then flat, flat, flat. And here, that looks like a low spot, but not the lowest spot. And here, that looks like it was the low spot when this LiDAR was flown. And then we see low spots again here. And that is a case where even a year's change can make a difference in where the lowest point is on that profile. So that shows again the changeability of the natural world there, that LiDAR is great. It's got this great tool. We can look at this and say, all right, there's our lowest point on this profile. Well, that could have changed. And that's why when you're doing your stream buffers, it's important to make sure you actually check where it is on the ground now, not where it was the last time you had an air photo taken or the last time the LiDAR was flown. Let's check out this gravel pit with the Profile tool. So go ahead there, click once, click twice. You can see we're going along that deposit there and then down. That looks like a cut. And then down, 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 up again. And that looks like the edge of the gravel pit. There's an interesting feature, potentially dangerous. Let's go ahead and turn on our satellite image. We can't really see a thing. We can see the operations reached up to its edges here, so nobody seems to have gone right up the center. Let's look at our canopy height model. Yes, that seems to have been left. But looking at our hillshade, it does seem to be something there. Let's investigate that with our Profile tool. One click to start, 2 clicks to finish, and see 1114.5 and down to 25 feet, 30 feet down below there. So that's a pretty steep drop there. Definitely would want to watch out for that. And I would guess that's a geological feature and not one carved out by a stream. Let's look at one more stream crossing. We already have a road here, but let's pretend we don't have that. It's in the best spot that it can be there, but let's pretend we had to go here for whatever reason. Look at our Google satellite. We can't really see the stream channel. We can see there's a run of conifer through there. But let's go ahead and use our profile tool. And we have to, again, select our layer, add that in, and then we're going to do 1 click to start, 2 clicks to stop. You'll see a nice gentle slope down to our low spot there. That looks like our stream channel, and then back up the other side to another bit of a bench there. And another curious feature here. Why does it go completely flat there? Is there anything interesting growing there? Is that an enriched site? Is there deposits of organic matter from up here accumulating down here, creating anything of interest? So you can spend all kinds of time interpreting this kind of data set, and for right now I encourage you to do that.